At least 18 people are dead in France, and the country just recorded the hottest day in its history. But the temperature on the thermometer is not what killed them. There's a second temperature, one almost no one talks about, called the wet bulb temperature. And it is the number that actually decides whether a human body can survive heat at all. In the next few minutes, you will understand exactly where that line sits, why it is lower than scientists believed, and why it is moving toward where you live. Right now, on two sides of the Atlantic at the same time, the planet is breaking heat records that have stood for generations. Across Western Europe, a severe heat wave is in progress, and the national records have been falling one after another. France just recorded the hottest day in its history. Paris pushed past 40 degrees Celsius and hit a June record of 40.9 degrees Celsius, about 106 degrees Fahrenheit. In Spain, the town of Estacion logged 43.7 degrees Celsius, and the country posted its highest daily average temperature since 1950. The United Kingdom broke its June record. Belgium, Germany, Ireland, Italy, and the Netherlands followed, each giving way in turn. And the records are not the part that should frighten you. In France alone, at least 18 people have died in this heat. Among the dead were 2 children and 3 elderly people, the two ends of the age range that heat science identifies as the most exposed. Dozens more drowned trying to cool off in rivers and lakes. At the same moment, on this side of the Atlantic, a heat dome built over the central and eastern United States, and forecasters called it the most widespread heat wave of the summer. The Weather Prediction Center, in its national discussion, used the words significant, dangerous, and record-breaking. It is anchored by a powerful upper-level ridge, and it peaks in the first days of July, rolling straight into the holiday weekend. Here is what almost no one is telling you. The temperature on the thermometer is not the number that decides whether you live or die in heat like this. There is a second temperature, one most people have never heard of, and it is the one that actually matters. That number is called the wet bulb temperature, and understanding it changes how you read every heat forecast for the rest of your life. The wet bulb temperature is not the air temperature you see on your phone. It is a measure of how much cooling power the air will actually give your body. And it is rising faster than the headline temperature. The line where it becomes deadly is lower than scientists believed even a few years ago. And it is moving toward the warm, humid, crowded places where most people on Earth actually live, including the eastern half of the United States. To understand why a single number can decide whether a human being survives, you have to start with what your body is doing every second of every hot day. Your body works constantly to hold its core temperature near 37 degrees Celsius, about 98.6 degrees Fahrenheit. Push too far above that, and your systems begin to fail in order. Your main defense against heat is sweating. Sweat evaporates off your skin, and as it evaporates, it carries heat away with it. It is the same physics that cools a wet cloth on the back of your neck or water kept in an unglazed clay pot. But that defense has a hidden condition, and this is the whole story. Evaporation only works if the air around you has room to accept more moisture. In dry air, your sweat evaporates almost instantly and the cooling is efficient. In humid air that is already nearly saturated, your sweat just beads up, drips off, and soaks your clothes while doing almost nothing to cool you. This is why a humid day at 95 degrees Fahrenheit can be more dangerous than a desert day at 110 degrees Fahrenheit. In the desert, your sweat is still evaporating, still pulling heat off your skin. In humid air, your body produces sweat and gets no cooling return at all. You are running the engine, and the brakes are gone. There is a second, quieter problem, too. When sweating fails to cool you, your body does not give up. It pushes more blood toward the skin to try to dump heat that way, which means your circulatory system is suddenly working overtime in the middle of a crisis. That extra strain is why so many heat deaths look, on paper, like something else entirely. The cooling system fails first, and the organ that finally gives out is the one that was forced to carry the load. And the people who pay first are the people least able to absorb that failure. Older adults sweat less efficiently, regulate their temperature more poorly, and more often carry conditions that heat makes worse. Infants are exposed. Outdoor laborers who cannot stop working are exposed. The poor, who often cannot reach anywhere cooler, are exposed. Heat is already the deadliest weather hazard in the United States, ahead of floods, ahead of tornadoes, ahead of hurricanes. And it kills far more people than the official record shows, because heat deaths are so often logged as cardiac events or strokes instead. So how do you measure the thing that actually matters? The air's ability to cool a body. You build a thermometer that sweats. The wet bulb temperature is measured by wrapping the bulb of a thermometer in a wet wick, a kind of wet sock, kept constantly damp. Water evaporating off that wick cools the bulb in exactly the same way sweat evaporating off your skin cools you. In dry air, a great deal of water evaporates, and the wet bulb reading sits far below the real air temperature. In saturated, soupy air, almost nothing evaporates, and the wet bulb reading climbs until it nearly meets the air temperature. That is the warning sign. The closer the wet bulb reading gets to the air temperature, the closer your body is to losing its ability to cool itself at all. When that wet thermometer can no longer cool itself, that is the signal that a human being standing next to it cannot either. So where exactly is the line? At what wet bulb temperature does the human body simply stop being able to keep up? Scientists call that point the limit of compensability. It is the point past which your body can no longer compensate for the heat coming in, and your core temperature starts to climb on its own, uncontrollably. Obviously, you cannot find that line by heating people until they die. So instead, researchers put volunteers in sealed heat and humidity chambers, raise the temperature and the humidity step by step, and track the volunteer's core temperature with an ingestible capsule. The exact moment that core temperature stops holding steady and begins to rise, that is the edge. For years, the number everyone quoted came from a study by Sherwood and Huber in the year 2010. They proposed a survival limit of 35 degrees Celsius on the wet bulb scale. The reasoning was that at a sustained 35 degrees wet bulb, a human could not survive even at rest in the shade with unlimited water. And at the time, that felt comfortably far away, because the hottest places on Earth were topping out around 31 degrees wet bulb. There was a margin. Then they actually tested it on people, and the margin shrank. The PSU Heat Project at Pennsylvania State University, with researchers including Daniel Vichelio, ran those chamber experiments on young, healthy adults in 2022. The real limit was not 35 degrees. For fit young subjects, it was closer to 30 to 31 degrees wet bulb, and lower still in hot, dry conditions. The theoretical ceiling had been too generous. The body gave out sooner than the math said it would, and then it got broader and more sobering. A 2025 review in the journal Nature Reviews Earth and Environment, led by Colin Matthews, pulled the science together and found there is not one universal threshold at all. There is a range running from about 19 degrees wet bulb to about 32 degrees, depending on your age, on how hard you're working, and on the exact mix of heat and humidity around you. Think about what that revision actually means. In the span of about 15 years, the science went from a single comfortable ceiling that almost nowhere on Earth could reach, to a measured, real-world range whose bottom edge can be touched by conditions that already occur in populated regions today. The number did not move because the planet suddenly changed. It moved because, for the first time, researchers stopped calculating the limit and started measuring it on actual human beings, and the human body turned out to be more fragile than the equations had assumed. Now, 19 degrees might sound survivable, even mild. This is the trap, so stay with me. A wet bulb temperature of 19 degrees is not 19 degrees on the thermometer on your wall. A wet bulb reading of 19 degrees corresponds to roughly 46 degrees Celsius, about 115 degrees Fahrenheit in dry air, or it corresponds to about 32 degrees Celsius, around 90 degrees Fahrenheit in very humid air. That 19-degree figure is the threshold for the most vulnerable person, an older adult who is exerting themselves. The 32-degree figure is closer to a fit young person at complete rest. So the line is not a single doom number. It is a range that depends on who you are and what you are doing. But it is real, it is measurable, and it is lower than anyone believed a decade ago. And the most important thing to understand is that this is not a far future hypothetical. A major city has already crossed it. In June of 2015, one of the most extreme humid heat events ever recorded settled over Karachi, Pakistan. The air temperature climbed as high as 45 degrees Celsius. But unlike the famous dry heat domes of Europe and Russia, this heat came wrapped in heavy moisture pulled off the Arabian Sea. So the wet bulb temperature, the number that actually matters, climbed right along with it. And then the city's defenses failed in sequence like dominoes. First, the electrical grid buckled under the demand, and the power went out. With no power, the pumps that moved the city's water stopped, and water grew scarce. And it was the month of Ramadan, so many residents were fasting, not drinking water during daylight, which is exactly when the heat was at its worst. Every layer of protection collapsed at the same time. In roughly 10 days, at least 1,200 people died, most of them from heat stroke and dehydration. The hospitals were overwhelmed. One medical center alone treated thousands of heat patients in a matter of days, and the morgues filled. The Eddy Foundation, which runs the largest morgue in Karachi, ran out of room after taking in around 650 bodies. Its cold storage filled completely, and the dead were left outside in the heat while families searched among them for the people they had lost. Later analysis found something that had almost never happened before in a major city. For something like 8 to 10% of that event's duration, Karachi crossed the uncompensable wet bulb threshold for older adults. For a slice of those 10 days, for the city's most vulnerable people, the air itself had become something a human body could not survive. Not uncomfortable, not dangerous, unsurvivable. Now here is the part that scrambles most people's mental picture of deadly heat. When you think of the worst heat disasters in modern memory, you probably think of Europe in 2003 or Russia in 2010, and those were catastrophes. The 2003 European heat wave killed on the order of 70,000 people across the continent, with as many as 3,400 dying in Paris alone. The 2010 Russian heat dome killed an estimated 55,000, the worst such disaster in that country's roughly 1,000 years of records, with the air thick with smoke from burning peat and forest. In 2021, a heat dome over the Pacific Northwest of North America pushed the small village of Lytton, British Columbia, to 49.6 degrees Celsius, 121 degrees Fahrenheit, a national record for all of Canada. But here is the strange truth. None of those events ever reached the dangerous wet bulb line because in all of them, the air was dry. They killed over days by slowly grinding down the bodies of the old and the sick, by overworking circulatory systems and kidneys until they failed. That is lethal arithmetic, and it is terrible. But it is not the same thing as the sudden, total shutdown of the body's cooling system that humid heat produces. The disasters that fill our history books were the survivable kind. The genuinely unsurvivable kind, the humid kind, has been rare so far. And that is the only reason most people have never even heard of the wet bulb limit. So why is this rare, unsurvivable kind of heat the thing to watch? Because the physics of a warming world manufactures it faster than anything else. Warmer air holds more water vapor. The relationship is called Clausius-Clapeyron, and the number is roughly 7% more water vapor for every single degree Celsius of warming. So in any place with a nearby moisture source, a warm ocean, a great river, a delta, fields of irrigated crops, rising temperature drags the humidity up along with it, and when the humidity rises, the wet bulb temperature climbs faster than the air temperature alone ever would. This is the trap hidden inside every heat forecast. A region can look at its predicted highs, decide they look survivable, and completely miss that the wet bulb temperature, the number that actually decides whether a body can shed its heat, is rising underneath the headline figure. It is being pulled up by the very moisture that the warming itself is adding. The thermometer says you are fine. The wet bulb says you are closer to the edge than you think. And now the geography. Because the question that matters is not whether this line exists somewhere far away. It is whether the line is moving toward where people actually live. It is. At 2 degrees Celsius of warming above pre-industrial levels, a threshold that on the current path could arrive in as little as 2 decades, dangerous, uncompensable conditions for older adults would cover roughly a third of the planet's land area, about 35%. And that land is not empty desert. It includes most of India. It includes most of the populated parts of China. And it includes most of the eastern United States, the warm, humid half of this country where the great majority of Americans live. That same 2 degrees of warming would roughly triple the land area where even younger, healthy adults face uncompensable heat. Pushed to 4 degrees of warming, and more than 60% of Earth's land surface could cross into dangerous wet bulb conditions for older adults, with some regions facing them almost continuously. The frequency changes too. That 2003 European heat wave, historically about a once-in-a-century event, is projected at 2 degrees of warming to come back around once every few years. And a humid event like Karachi, which crossed the older adult line for just a sliver of its duration, would at 2 degrees cross that line for younger adults as well, and at 4 degrees would cross the older adult threshold for something like 90% of its duration. The thing that has almost never happened becomes the thing that happens most summers, and you're watching the early version of this mechanism play out in real time this week. Heat plus humidity plus nights that refuse to cool down, falling hardest on the very young and the very old. The children and elderly people among France's dead this week are not a coincidence. They are the exact signature the science predicts. What makes the eastern United States such a concern is not that it is the hottest place on the map. It is that it checks every box the wet bulb math cares about. It is densely populated, it sits beside warm water, and its summers are humid by nature. Those are precisely the ingredients that push the wet bulb temperature up faster than the thermometer, in the place where tens of millions of people already live. The danger is not arriving from some distant tropical zone. It is being built, degree by degree, in our own backyard. So the obvious question is, Can't we just run the air conditioning? And yes, air conditioning is the single most important tool we have for surviving uncompensable heat. But it is a trap with four walls, and you need to see all four. The first wall is cost. Air conditioning is expensive and energy hungry, and the people most exposed to deadly heat are very often the people least able to afford to run it, both inside wealthy nations and across the poorer, hotter regions, where the danger is highest. The second wall is that air conditioning does not destroy heat, it just moves it. Cooling a building pumps that heat out into the street, and in a dense city, all those units together make the outdoor air hotter, intensifying what is called the urban heat island. The third wall is the grid. Power systems were never built for every household to run cooling at full blast on the same brutal afternoon. The most stressful moment for a power grid is the single hottest day of the year, which is exactly the moment everyone needs it most, and the moment it is most likely to fail. The worst-case scenario that keeps experts up at night is a tropical cyclone knocking out the power, followed by a humid heat wave moving in right behind it, with no way to cool anyone at all. And that connects directly to what is happening across the United States this week. As of yesterday, the active alert tally included 21 extreme heat warnings, 19 extreme heat watches, and 48 heat advisories. Heat indices are forecast to reach or exceed 105 to 110 degrees Fahrenheit from the Midwest and Mississippi Valley to the East Coast. But the most telling number comes after dark. Overnight, low temperatures are forecast to stay in the upper 70s to low 80s Fahrenheit across much of the Northeast and Midwest, warm enough to break records for nighttime minimums. That is the silent multiplier. When the night never cools, the body never gets its recovery window, the strain just accumulates and the death toll climbs. The fourth wall is the cruelest one. The more the world leans on air conditioning, the more it feeds the warming that is driving the heat. Cooling already accounts for around 3% of global greenhouse gas emissions, and the International Energy Agency projects that the number of air conditioning units worldwide will nearly triple by 2050. We are cooling ourselves by warming the planet. And before anyone asks, no, this heat is not being engineered. The claim that facilities like a HARP or cloud seeding are manufacturing these heat domes does not survive contact with the math. Those facilities operate at the scale of a few megawatts, while the energy embodied in a continental heat dome is many orders of magnitude larger. Cloud seeding can nudge a bit of rain out of an existing cloud, but it cannot build a hemispheric ridge of high pressure. The records are not faked either. They line up across thousands of independent stations, across many countries, across continuous data going back more than a century, and across separate national weather agencies that all agree. This is real, and the cause is well understood. So what do you actually watch for now? In the short term, watch the next several days across the central and eastern United States as that ridge peaks into the holiday weekend, and watch those overnight lows as closely as the daytime highs because the nights are where this heat does its quiet damage. Watch the humidity numbers, not just the temperature, because in the east, it is the moisture that turns a hot day into a dangerous one. In the longer term, understand that the outcome is not yet written. The wet bulb line is real, and it is approaching. But how many people end up on the wrong side of it is still a matter of choices being made right now. The single most powerful action is moving power grids to clean energy fast enough to meet soaring cooling demand without burning more carbon. Beyond that, cities can fight heat directly with reflective white roofs and green roofs with trees and shade, with networks of public cooling centers with hardened and modernized grids, and with deliberate plans to find and protect the most vulnerable, the old, the isolated, and the poor, before the next heat wave turns deadly. The thermometer outside your window is going to keep breaking records. But now you know it was never the number that mattered. The one that matters is the wet bulb temperature, the line where the human body simply stops being able to cool itself. That line is lower than we thought. It is rising faster than the heat we can feel. And it is moving toward the places where we live. The records are not the story. The line is. And it is closer than almost anyone is telling you.